So that as we look at multiplicity of zeros, what is this? A multiplicity of 0 is the number of times a 0 appears. It's the number of times a 0 appears. So if I were to look at x minus 1 equals 0, this says x equals 1. It only appears once, so I would say this is multiplicity, M-U-L-T-I, 1, because it only appears once. However, if I were to look at x minus 1 times x minus 1, which is really x minus 1 squared, this would be x equal 1, x equal 1. This appears twice. This is multiplicity. 2. We normally would write just x equal 1. But in this instance, this is going to have some meaning to us. X equal 1 multiplicity, and I'll do MULT for multiplicity, multiplicity 2. That says that 0 appears twice. If I had x minus 1 cubed equals 0, this would be x minus 1 times x minus 1 times x minus 1. It's x minus 1 times itself 3 times equals 0. Or x equal 1, x equal 1, x equal 1. It appears 3 times. This is multiplicity 3. It's the number of times the 0 appears. Again, we normally write x equal 1 multiplicity 3, which says that basically it has a factor of x minus 1 raised to the 3rd power. So in general, how do I know a multiplicity when I see one?
By the power. Exponent.
Power where?
The leading coefficient.
How do I know the multiplicity?
How many?
Well, if I had x minus 1 to the n power, what's the multiplicity? N. It's the power on the factor. If the factor has power 1, it's multiplicity 1. If the factor has power 2, it's multiplicity 2, because that's how many times that factor appears. So multiplicity is the number of times that a 0 appears. Number of times that a 0 appears.
Do you have attendance?
Now, from a graphical point of view, how do I know what multiplicity is? Well, if a multiplicity 1 would be something like x minus 1. Now, if I were to graph x minus 1, what does x minus 1 look like? What does it look like if you were to graph it? Y equal x minus 1 is a what? It's a line. Looks like a line. So that means that if I were to graph anything of multiplicity 1, it cuts the axis and looks like a line. It could be this way or it could be that way. But it looks like a line as it goes through the x-axis. Now multiplicity 2 would be something like x minus 1 squared. This guy looks like, as a graph, what? A U, or a parabola, right? U-shaped graph of parabola. Now, that would mean that if I were to look at a multiplicity 2 at x equal 1, I'd have something which either opens up, or I could have something that opens down. It looks like a parabola. If I were looking at multiplicity 3, that would be x minus 1 cubed. This looks like, as a graph, what? Looks like an S curve. Looks like x cubed. Looks like x cubed. So it's an S curve. That means if I were to look at the graph, it's either an S curve looking like that, or an S curve looking like that. It's an S curve. Now here's the interesting part of it. This defines multiplicity 1, always looks like a line. Multiplicity 2 represents the even functions. So if I say multiplicity even is a parabola. And x cubed represents multiplicity odd. So multiplicity odd is always going to be an S curve. The difference is the parabola is either narrower or wider, where it interacts with the 0. Same thing with the multiplicity odd. It either comes in as a kind of like a flat looking S, or it's a steep looking S, but it's still an S as it interacts with the x-axis. Multiplicities in polynomials gives us an immense amount of information that we wouldn't have had otherwise.